Today we're going to talk about the algebra functions. The whole idea behind this is we're taking what we already talked about of functions and the basics of functions and applying arithmetic to them between two or more functions to create new functions. We'll also explore a little bit today of how the domain changes over time, but pretty much that requires inequalities to really explore it in depth, but we'll just cover the basics of it in general. Feel free to like, comment, subscribe to the channel, and let's hop right into it. Alright, so before we even get started, oops, sorry about that, move that up a little bit. Alright, before we get started, let's f and g pretty much let these two, f and g, be functions. This is common notation for math, especially when you write proofs out. And pretty much all this is saying is, okay, with respect to x or whatever variable, so this will be a function of x so f of x and g of x, both functions of x. They're both, we define them as functions. And then the domain of the combined function, whenever we apply any operation to them, is what f and g have in common. So pretty much what we're saying in this note here, we compare f and g, and whatever they have in common, whatever makes them defined, what all makes both of them combined, defined in common, is the domain of the new combined function. And anything that we don't have, anything not in common, we exclude any pieces not in those domains. So we have 5 operations for functions. Adding, we add function 1 and 2, so f of x plus g of x, and we get f plus g of x, the new combined function. Subtraction. Function 1 minus function 2, f of x minus g of x, is f minus g of x. Multiplication, we have f of x times g of x. Function 1 times function 2 gives us the combined function f times g of x. Division. Alright, this is a special case of what we call the rational function, where g of x can equal 0, so it's function 1 divided by function 2. F of x minus f of x over g of x gives us f divided by g of x, the combined function. Then we have composition, which is a special topic that requires, which to really talk about it, we should talk about it in a whole separate lesson. Alright, so let's give an example of adding functions. X squared minus 3 is equal to f of x. And g of x is equal to 4x plus 5. What is the function f plus g of x? Alright, so basically we already defined up in here that f plus g of x is equal to f plus g of x. So we write that out by commutative, the same statements. And essentially, in this case, because it's addition, but now we just combine like terms. Okay, so there's nothing in common with x squared. Okay, nothing in common with 4x. I use these lines to signal I already looked at them. Alright, and 5 minus 3 is 2, so that gives it, this is equal to f of x. This is equal to f plus g of x. So the combined function is x squared plus 4x plus 2, and that is a quadratic function. And this is a polynomial, so its domain. So function g of x is a polynomial. Its domain is negative infinity to positive infinity. So all polynomials, I'll make a note real quick. And same here for this case, it's a polynomial. pretty much talk about polynomial functions. There isn't anything that will make these undefined. So this is all real numbers for both. So this is interval notation, more commonly as superscript r, saying, okay, all real numbers are these functions. And since we added two polynomials together, nothing makes these two functions undefined. These are, the domain of the new function is negative infinity to positive infinity, or all real numbers. Okay. Let's do an example of subtraction. All right. All right. Subtraction. Using the same numbers, of course, this is the same function. So let's f of x equal x squared minus 3, and let g of x equal 4x plus 5. What is f minus g of x? Okay, sorry about that, guys. Pretty much what we're going to do here is, so by definition, f minus g of x is equal to f of x minus g of x. The order of this really does matter now because g of x minus f of x is not the same as f of x minus g of x, of course. The reason why in the previous example, why I switched them around by mistake, was because of the commutative property of addition, which we talked about. Multiplication and addition are commutative. Alright, so we write out the definition, of course, that's the first step. Then we're going to plug in the functions. So x squared minus 3, sorry guys, minus, this is where we, alright, so minus, and then I always put things in parentheses because of minus signs when I'm plugging in. It's signals I'm plugging things in. Okay. So then by the distributive property, there's a negative 1 right here. There's an invisible negative 1, pretty much. And you're going to distribute the negative across. Okay? That gives us x squared minus 3 minus 4x plus 5. X squared, combine like terms, so then nothing with x squared. Alright, that should be a minus. Alright, so nothing, no 4x, and minus 3 minus 5, that's minus 8. If you notice this, these two are both polynomials. Both of these were polynomials, so there's nothing to exclude. This domain was all real numbers. This domain was all real numbers. So pretty much we say, okay, this is equal to f minus g of x, and its domain is all real numbers. Okay. Multiplication. Okay. So using the same examples too. Right, f of x is equal to x squared minus 3, g of x is equal to 4x plus 5. I always write that f times g of x is equal to what? Alright, so write the definition out, like always. It's equal to g of x times f of x. Alright, like I said, multiplication is commutative, so either order I write it in works. Then we're going to so then we're going to plug in the functions. Okay, so we have x squared minus 3, 4x plus 5. Alright. Now if you guys want, now there's two ways of doing this. You could FOIL it out, or you could use the box method. For this is what we call binomials. This is what we call the distributive property. We're applying it. You could use the box method. In larger polynomials, it helps out a lot more, but binomials, FOIL works just fine. So we're going to do that. So taking the first term. Alright, so x squared. So we have 4x cubed. Alright, so we have x squared times 4x. Take it, multiply by this term. Plus, now we have x squared times 5x. 5x squared. Okay. Minus 3. So plus minus 3 times 4x. Minus, or plus, minus 3 times 5. Okay. So cleaning this up a little bit, we have 4x cubed. By the power properties, if we have the same base but different exponents, we could add them. We multiply this term right here, the numbers, and we add the variables, and we add the powers on the variables. All right, 5x squared stays the same. Minus 12x plus minus 15. This is also a polynomial, so its domain is negative infinity to positive infinity. Alright, lastly we have division. So this would take a whole sheet itself. This is f over g of x. Alright, using the same examples from previous. So we're trying to find f divided by g of x. So write the definition out. Is equal to, alright, so we have, so f of x is x squared minus 3, g of x is 4x plus 5. Alright, so if you guys remember, there was a special case. This is a rational function. Alright, so this is what the function is. Alrighty, so this is done. The function is done. The combined function is done because there's no because there isn't anything to clean up. So let's find the domain. Alright, to do so first, we need to check for zeros. And in a rational function, that's in the numerator. And then we check also in the denominator for undefined. So the easiest way to start is with the denominator. 4x plus 5 is equal to 0. It cannot equal 0. Alright. Essentially, what we're going to do is we're going to subtract 5 over 4. 4x is equal to negative 5. Oops, sorry, you guys can't see that. Then you're going to divide by 4. X is equal to negative 5 over 4. Alright, cannot equal. So therefore, so that's the domain of this function. An easier way of writing this is negative infinity to negative 5 over 4. Union negative 5 over 4 to infinity. But we'll talk about that when we cover rational functions. With that being said, guys, see you guys next video.